Hi everyone, this is my submission for the weekend challenge that was based on the theme to build something for the planet, and it was a general theme, right? You can build anything that will represent or celebrate our planet Earth, and I thought what better way to celebrate than actually save it. So yeah, I just built an website or basically an auditor which will connect to your Snowflake account, and which will analyze all the tables and SQL queries and provide you with optimization or some actions regarding to that. So basically, by optimizing or removing the redundant tables which aren't needed anymore, you are basically reducing the redundant storage. Like the storage is being lying there on the data center, and you are just wasting some digital space because of that. So basically, by doing such actions, we can actually reduce or make an impact on the CO2 emissions that are usually generated by these data centers, and reduce the water wastage as well that is used to maintain such data centers. So let us start with the demo. So basically for the login page, I did just a simple thing that I need to connect to my Snowflake account. So give me a JSON file which has basically a config file which has this following details. So your user, password, account, the warehouse details, the database and schema because that is important, and the role. We are also asking for the role because there may be some privileges associated with the account and which may or may not provide you with some accesses, right? So let us get started. Let us just use a file. I have built a Snowflake account for this purpose. Let us just log into the dashboard. So for the purpose of this, I am using a schema that is already provided to be used as an example in Snowflake, and the size of the schema is around 10 terabytes, right? So for this, let us do one thing. Let us gather the statistics for this database. What we are doing first is I want to get an overview of my database, my schema, right? I want to just know what data lies there, what tables are there, what is the row size, etc. So let us just do that first. It will do a simple thing. It will check the backend by executing a simple SQL query and get all the table names with the rows, the size, and the last access date. So this will provide the end user with an overall idea that when was this table last used. So, for example, this was used in 2024. The row count, this has this many rows, and this is using this many MBs on the storage, right? We can also perform a sorting on this. So basically I can sort via the number of rows or even the uh, even on the size of the table to get an overall idea. Now we can see some sustainability metrics. So estimated annual CO2 saved. Right now we haven't done any actions, so it is just showing normal message that we it is pending, and the zombie tables count, and we haven't done that either, so it is also showing on message. So let us first try to identify the zombie tables. What are zombie tables? Zombie tables are basically tables which you haven't accessed in a while and are just lying around in your storage, and aren't used for any purposes. To give you a simple example, let me just click on the button first. Yeah. Let us also go through the code as well for the zombie. So we are just selecting the tables that are older than 30 days. So which we just want, we wanted to filter at the database layer itself. So we added a filter, and we're just fetching 50 tables because we don't want to increase the context that is passed to the uh, LLM model. Now let us just find the prompt. Yes, you are a database carbon efficiency expert. We have queried our snowflake schema and identified the following inactive zombie tables unaltered in greater than 30 days, and we are providing the table string as it is. Use the heuristic that 1 GB of cloud storage emits approximately zero point 0.7 kg of CO2 per year. Task: explain briefly why retaining unused tables waste storage, compute, and emits unnecessary CO2. So we're briefly generating a report explaining the end user why they should why they should drop or archive these tables, and provide a report in a strict tabular format markdown. The report must include these columns, right? So that was to render it on the website correctly. Okay, we got the results. So it first explains why these tables are a waste of carbon space and why they would, reduce the CO2 emissions. So this is for storage wastage, compute wastage, because when you are searching for the schema for tables, you will need to search. I mean, this table would hinder in the search as well. Unnecessary CO2 emissions. So, give you an example on a real life example for zombie tables. Let's say you are creating a backup to migrate, and after that you forgot to delete your backup table. So you just created a duplicate copy and you forgot to delete the backup table. So in that case, it will scan all the tables that are not used in the last 30 days, and the backup table will show up in such cases. So this report gives me an idea of all of the tables which are not accessed in the last 30 days, and recommendation for each of these tables. So archive or delete, right? Because there is a lot of data still present in these tables. The recommendation is to archive to a cheaper storage, because we may need, like, there will be some reports that could be run yearly or quarterly, so it is better to archive, and before that to check with the end user. And there are some cases where the data is, like, the storage size is pretty low, so the recommendation is to delete after confirmation. So let us do one thing. Yes, let us one thing. Let's just archive this table. So it approximates that at 815 or 816 kg of CO2 is saved by archiving this table. Now let's see. Let's just drop. Okay, the size is basically approx zero point zero 0.01 MBs for this table. So let's just drop it. Yeah, the approximate after round off, we are almost saving up 0 kgs, right? Because it was the least data stored in that this case. So basically, this will give you zombie tables count. Now let's navigate back to the dashboard. Yes, we got the updated count that for this session we have saved 816 kg of per year of CO2, and we did find 22 zombie tables still exist, and we can still do perform actions for that. Now on to our next feature, which is to identify the high compute queries. So let's click on that. So it gives you a list of all the executed queries that are in your schema with the data that is scanned and the time it took for this particular query, as well as the query ID. So we are also providing the query ID in this report because we want the end user to, they may want to check on their end with what this particular query is doing, and the query ID is pretty important if you want to use some query analyzer, SQL analyzer tools, right? So we are also providing the queries. So for each of these queries, I can get the optimization report. So let's do it and navigate back to the Visual Studio to get the prompt. So the prompt in this case is, you are carbon efficiency database expert, as is. The following SQL query scanned this many GB and took this time, and this represents a potentially high carbon footprint. So we'll be providing the raw SQL here in the prompt itself. The task will be to rewrite this SQL to be more green. Add parts. Examples are add partitioning, prune columns, use better joins, explain the estimated percentage of energy compute reduction and projected annual CO2 savings. We just did this for the markdown so we can efficiently extract the data for the CO2. Suggest if this data should be archived or if it's rarely used. So that is another thing. And provide the final optimized SQL query in a single markdown code block at the end of the response. So yeah, that's it. So we got the output for this particular query. So we were getting a full report that what could be the sum of the strategies that could reduce in the computation power to needed to execute this query. So clustering, if it's not already clustered, add a clustering key on the join condition, I believe, right? Will significantly reduce the amount of data scanned during the join operation. Micro-partitioning benefits the Snowflake's micro-partitioning benefits greatly from well-chosen clustering keys, allowing to prune micro-partitions that don't contain the relevant values. Right. The materialized view. So the pre-computation in this case, it is asking us to already build a temp table, and it already stores the aggregated values, making the subsequent queries easier and faster to compute. Some assumptions are given by the model as well as the query frequency. So it assumes that it is run daily because we aren't giving it the frequency. That could be a feature for the future improvements in this project. So some consumption details, energy reduction, projected annual CO2 savings. Uh, if it's prime candidate as per the business analysis, we can archive this data, right? So it asks the user to basically identify the access patterns and retention policies, and even it gives if it's stored in cloud, how it could be done based on the access patterns. So if it's a hot data, we can store in the table. If it's a warm data, different schema with less frequent backups to reduce the storage. And if it's a cold data, that is, it is not run daily and a long-term low-cost storage solution, S3 Glacier or Snowflake's long-term storage would be better for that case. And at the end, it is giving the final optimized query, which would be based on the materialized view that was given in the suggestion. So let's just accept this suggestion. Okay, we saved 45 kgs of CO2. Let's navigate back to the dashboard. So yeah, it is updated in the dashboard for that particular query, and yeah, that's it for the project. We can just log out and the session details will be erased for this. Thanks for watching.